See your question number 9. In this, fx is given modulus x minus 1, where x is any real number, and we have to prove that fx is not differentiable at x equals to 1. Not differentiable we have to prove. So for proving differentiable, we will take LHD and RHD, left hand derivative and right hand derivative. On the point which is asking, that point we will take. He is asking on x equals to 1, so we will take x is less than 1, x is greater than 1. Okay. For left hand side derivative, we will take less than 1, and right hand side we will take greater than 1. Okay. After that, how to find this LHD and RHD? We will take limit h tends to 0 negative. Okay, there is h. So this derivative formula is same like 11th class we studied. Okay, fx minus fa upon h. But for LHD we will take minus h here. Okay, and for RHD we will take positive h, and upper side also f1 minus h and there f plus h. So see the difference between both. Okay, here first difference is 1 minus h, and for RHD 1 plus h, and downside minus h, and for RHD positive h. So this is about your formula. Why I have taken 1 minus h and 1 plus h? Why not 2? Why not 3? Because at x equals to 1 he is asking. So for x is less than 1 means 1 minus h, and x is greater than 1. Greater than 1 means 1 plus h. Clear? So after that, how to put the value of this function? See this, f1 minus h value we will find from this function. See this function once. Fx is modulus of x minus 1. So at the place of x there is 1 minus h. Okay, so this x value is 1 minus h. We will put here x value 1 minus h. So what will come? Modulus x value is 1 minus h. After that, by putting value of x, that minus 1 is also remaining here. So this is your value of function f1 minus h, which I have written here. Same. Okay, and f1, how this f1 value came, this 1 minus 1 modulus? See again your function fx. Okay, go in your fx function again, modulus of x minus 1. So here f1 means x value 1 we have to put. So if we will put x value 1 here, then it will come modulus of 1 minus 1. Clear? So the same like the value we will put on that side. Difference is only this minus h and positive h. The same type value we will put in RHD. Okay, after that 1 minus 1 will become 0. Here 1 to 1 will cancel, only minus h will remain in modulus. And after that, this minus h modulus is positive h, because negative of modulus of any negative number is positive, and this modulus of 0 is 0. That's why h and minus h will cancel, minus 1 will come your LHD, left hand derivative. As it is here, modulus h is h, modulus 0 means 0, then h and h will cancel with each other, then it will come 1. So why it is coming minus 1 and why it is coming 1? So most important thing to remember is this minus h for LHD and positive h for RHD. Because of this negative, here it comes minus 1. Because of this positive term, it is coming positive. So you can see LHD is not equal to RHD. So fx is not differentiable at x equals to 1. We are done. Now come into question number 10. In question number 10, this function is called maximum integer function. Okay, it is not modulus, it is big bracket x, maximum integer function, and he is asking it is not differentiable again, but on 2 points, x equals to 1 also and x equals to 2 also. So firstly we will take only x equals to 1. Okay, so same procedure we will follow. LHD x is less than 1, RHD x is greater than 1. And how this function came, this is important. So we will put in this function keep in mind. Fx is modulus of x. So what will be your 1 minus h and f1 function. Okay, so what will be your 1 minus h function? We will put the value in fx. Okay, h value we will put 1 minus h, x value 1 minus h, and here x value we will put 1 plus h, same like we have put there. Okay, upper side question number 9. But the value of this is important, how these values of 1 minus h and 1 plus h came. Maximum integer of 1 minus h means if any small quantity h you will subtract from 1, so what will be its maximum value? If any small quantity we will subtract from 1, so it will reach to 0. Okay, 1 minus h is any small quantity, so it will become 0. But if you will add any small quantity into 1, h is any small quantity here, so if you will add anything in 1, so it will not become 2 or 3 or 4 or 5, it will become always 1, because it is greatest integer function, so its greatest value is 1. Okay, it cannot be more than 1, so 1 plus h value will remain 1. Okay, and this modulus greatest integer of 1 will become 1 as it is, greatest integer of 1 will become 1. After that 1 upon h, minus 2 minus will cancel in left hand side, so 1 upon h. Now we will put h value 0, at where h value 0 we will put, so 1 upon 0, 1 upon 0 means infinity, so your LHD is coming infinity in that side, and in this side 1 minus 1 will cancel, it will become 0 upper side, so 0 upon h will become 0. So you can see your LHD is infinity and RHD is 0, so which is not equal, so it is not differentiable at x equals to 1. So how to do this? X equals to 2 in second part, like first part I have done. So wherever I have put 1, okay, this 1 we have to replace by 2, and you have to do yourself this second part.